Good evening, sir.
Very good evening, Congo. How are you?
Yes, sir, I'm fine.
Great.
Good evening, sir.
Very good evening. How are you, Sankar?
Fine, sir.
Where is Thorn? Nitish?
I don't know, sir.
Sir, Nitish will join a bit late, sir.
Why?
Sir, he's outside.
Okay.
He'll join like 10 minutes.
That means we shall start, right?
Yes, sir.
Is screen visible now?
Yes, sir.
Okay. So actually today we had to study the next chapter, that is the study of hydrogen. Hydrogen unit we had to start.
Oh, okay, sir. We'll start.
Sure. So let me write it here.
I'll just bring my pen, sir.
Hydrogen. So you already know that this hydrogen, its symbol is H, right? Am I audible? Sankalp, can you hear me?
Yes, sir.
So hydrogen, its symbol is H, and we know that its atomic number is 1, right? So, so its electronic configuration, that means it has only one electron in its valence shell. So I can say that in this hydrogen, the valence electrons, that's equal to 1, and also its valency is also equal to 1, right? Valency is also equal to 1. Now, if we draw its electron dot structure, we know that this hydrogen, if its atomic number is 1, so what it indicates? It indicates that it has one proton, right?
Yes,
Yes,
sir.
sir.
There is one proton, and similarly there will be one electron, because number of proton it is equal to the number of electrons, right?
Yes,
Yes,
sir.
sir.
So can you tell me how many neutrons will be there?
Zero, sir.
Yeah, there is
Yes, sir.
zero neutron. There isn't any neutron in this. If we talk of normal hydrogen, that's your protium. Actually, hydrogen, it exists in three isotopes, right?
Yes, sir. Protium, deuterium, and tritium.
Very good. So we will also discuss the structure of all these isotopes here. So we are here having number first is the protium, that's 1H1. Second will be the deuterium, that's 1H2. And the third one will be the tritium, that's 1H3. So this is your protium. So in protium there will be zero neutron, but in case of deuterium there will be one neutron, right?
Yes, sir.
And in
And
case
in
of,
tritium, there'll be two.
there will be exactly the two neutrons. So if I just write here that electrons and protons and neutrons in all these. So in case of protium, there will be one electron. In case of deuterium, there will be also one electron. In case of tritium, there will be also one electron, right?
Yes, sir.
But if we just talk of protons, what will be the number of protons in all these?
Sir,
All will
protons
have
one in everything, sir.
exactly one proton will be in each one. And if we just talk of neutron, neutron is different. So here it will
Yes,
be
sir.
0. and here it will be 1, and here it will be 2. So if you have to just to draw the structure of this protium, how you will draw? That means there is only one proton and there is zero neutron. So you will just write one proton. That is proton. It actually has positive charge. So +1. There is one
Yes, sir.
proton inside the nucleus, and then there is one electron outside this, which revolves in the first shell, right? This will be the
Yes,
electron
sir.
dot structure of the first isotope, that is the protium. Now, similarly, if we just talk of the structure of deuterium, there is one proton and there is also one neutron. So you will just write 1p plus 1n. So one proton and one neutron is inside the nucleus.
Yes,
And
sir.
exactly, there is only one electron outside, so it revolves in the shell. That is the first shell, that is the key shell, right? Here it
Yes,
will also be the key shell, the first shell. Then we are just having the next one. Next is our what? Tritium. It has one proton and it has two neutrons. So 1p plus 2n neutron. This will be in the nucleus, and electron will be here also only one, which revolves around the nucleus, also in the key shell. Got it?
yes, sir.
Pankaj, can you hear me?
Oh,
Shankar.
hello.
Yes,
Hello,
can you hear me?
I'm there, sir.
Why you are not
Yes, sir.
responding?
I'm just sick, sir. That's why I keep cough. Sir,
Oh,
I keep sneezing and coughing, sir. That's why I muted myself.
Use and
okay.
mute, sir.
No problem. Get well soon. So,
Hello.
okay, okay. So we are having these three isotopes of hydrogen, right? And each of these isotopes, they will have only one proton, or we can say only one electron. So that means we can say
Yes,
these
sir.
isotopes, that means we can say that these isotopes, they have same chemical property. Why? Because they have same number of electrons. So isotopes have, I will write it here, they have same chemical properties. They have same chemical properties. But if we just talk of the physical property,
They are
so
different.
they are different, exactly. So but different physical properties. That means in this chapter, whatever we are discussing, it will be all related to this hydrogen, its preparation, its properties, its structure, its electronic configuration, right? Everything. So but different physical properties. Now can you tell me that why this is known as hydrogen? It is also known as
Sir,
dihydrogen, isn't it? You can call it. Yes.
yes, sir. Because its atomic number is 2.
Exact. See, no, atomic number is one hydrogen. I am saying that why it is known as
Sorry, sir. The atomicity. My bad.
exactly, exactly. Because its atomicity is 2. That's why whenever we write the hydrogen, we write it as H2, right?
Yes, sir.
So when atomicity is 2, so that's why it is known as dihydrogen. So it exists as H2 and it exists in the gaseous state, so it is a gas. So
So it's called
hydrogen is a gas,
hydrogen.
and
So
yes,
it's
it
called
is.
hydrogen because it
Okay, tell me.
generates water. Hydro is
Exactly.
water. Gen is generator.
Very good. Hydro, it means water. Just if we talk of hydroelectricity, what do you mean by hydroelectricity? Hydroelectricity means
Sir,
electricity produced
from
from water.
dams they collect water and then they
Exactly, exactly.
make
So
electricity.
hydro means water, and gen, it means the generator. That means which is water generating, water producing. So how it produces water, I will show it on the next page. Have you noted down this? Shall I move to the next page?
1 second, sir.
Okay.
Yes, sir. Done, sir.
1 second, sir. Done, sir.
Okay. So let's see why it is known as hydrogen. I told that hydro means water and gen means generator. So that means it is water generating, or we can say hydrogen is water producer. That means it produces the water. We can prepare the water from this hydrogen. So let's see how. Simply when we react this hydrogen gas with the oxygen, it results in the formation of water. I hope you
Sir,
can balance it, isn't it? It is easy, twice here.
two here and two there.
Exactly. Now, can you tell me that where this reaction actually takes place? Where can we prepare this water exactly? There is a cell which is known as fuel cell. There are different types of cells. In the fuel cell, we can produce this water. Reaction will be the same. That is hydrogen gas. We
So
are
it's like
reacting
apparatus. So is it the apparatus in which it's like
prepared.
created?
Exactly. It is just see, we are having three different types of cells which you will actually study in the higher classes. One type of cell is known as primary cell. Primary cell is just your dry cell which you are using in your just the torch and just any electronic devices like radios. We are using those primary cells. Then we are having the secondary cell. Secondary cell is that which is rechargeable. Just we are using those batteries which are in our mobile phones.
Oh, so it's
uh,
a battery, sir.
exactly, this is secondary cell. Then the third type of cell is your fuel cell. So fuel cell is that cell which also generates the electricity and it also produces the water. So water is prepared here in this fuel cell. So you have to remember this is very important, fuel cell.
Oh,
So in
okay.
this exactly, so in this type of cell we are using the fuel is actually here the hydrogen gas and oxygen. So hydrogen, it is known as a rocket fuel. You will remember that hydrogen is known as rocket fuel because its calorific value is very high.
Yes,
Hydrogen
sir.
is known as rocket fuel. So that means it is used as a fuel in rockets, right?
Yes, sir.
Yes, it has very high calorific value. And do you understand what is calorific value?
Yes, sir. We understand.
Okay, what is that? What is calorific value? Can you define? It has high calorific value.
Sir,
Calorific
it's the
value,
burning rate, sir.
it is actually yeah, the amount of heat energy produced
It'll quickly burn.
when 1 gram of fuel is burned. I will write it here. What is calorific value? So calorific value, it means amount of heat produced, amount of heat energy produced when 1 gram of, so this is important that we are just taking here the 1 gram. So when 1 gram of fuel is burned in excess of air, so this is called the calorific value. And if we just talk of this hydrogen gas, its calorific value is nearly 150 kilojoule. So that's very high. So that is why it is used as a rocket fuel. It's very important. You have to remember that this hydrogen, it is used as a rocket fuel because of its very high calorific value. Got it?
Yes, sir.
Okay. So this was the introduction of this. What is actually the hydrogen? Hydro means water and gen means generator. So it is water generating. Now this is known as dihydrogen because its atom stage 2. It is a diatomic gas. And this hydrogen, where it is its position? So what is its position? This is the first question which will be asked in the exam. This is very important, that the position of hydrogen in the periodic table. First of all, you have to remember that if you just see the position of this hydrogen, it is just there in the group first, isn't it?
Yes, sir.
It is just in the group first. And in which period it is?
Period one, sir.
Yes, so that means group first and first period. So it belongs to group first and first period. For example, if we just see first, it is the hydrogen, then we are having the alkali metals, that is lithium, sodium, potassium, rubidium, cesium. So you have to remember that if we just see the position in the modern or the long form of periodic table, it will be just there in the group first and in the first period. But important is that its position is anomalous. So hydrogen has anomalous position. What is that?
Sir,
Anomalous
one and
means,
one,
anomalous means
like
that
group one and phosphine.
no, anomalous actually means that its properties, some of its property they resemble with group first, but along with that, its properties also resemble with group 17, that is with halogens. And similarly,
Oh,
it differs from the group first, and it also differs from group 17. So that means this hydrogen could have also been placed in group 17, but it's not there. So its position is anomalous, right?
yes, sir.
Okay, I will write it here that anomalous means it actually hydrogen resembles with group 17 elements, right? It resembles with
Yes,
group
sir.
17 elements as well as with alkali metals, right? As well as with alkali metals. Alkali metals are just from lithium, sodium, potassium, right? As well as with
Yes, sir.
alkali metals. And I have told you that what are actually alkali metals, why they are known as alkali metals, right? Because actually alkali means water soluble base. They all form water soluble base. So first thing is that hydrogen, it resembles with group 17 elements as well as with alkali metals. But important is that it also differs, but it also differs from alkali metals and halogens, that is group 17. It also differs from alkali metals and halogens. So that means first thing is that it resembles with both these groups, that is your alkali metals and halogens, but also it differs from alkali metals and halogens. So that is why
Yes,
it has anomalous. And now it shows anomalous behavior. That means its properties doesn't resemble with these alkali metals. And similarly, when we just talk of group 17, that is halogens, it resembles in few properties, but it also differs in few properties. So that is why this hydrogen, it doesn't has the exact position in the periodic table. That's why we say it has anomalous position. Its position is anomalous. Mm, it is not properly placed. So let us see
yes, sir.
how it resembles with the group 17 as well as with the alkali metals, and then we will see how it differs.
Sir,
Resemblance, yes,
sir, is that why like in like I have a periodic table in that like hydrogen is there in both group 1 and group 17, but then in group 17 it's like faded, sir. It's not
exactly,
it's
exactly.
like
That is why, because I told that it resembles with the halogens. When I will just write the properties, you will just yourself check that it has various properties which are similar with halogens. So that's why it could have been also placed there with the group 17, that is halogens. So let us see first resemblance with alkali metals, then we will see the resemblance with halogens, and then we will see the differences. So have you noted down this? Shall I move to the next page?
yes, sir.
Yes, sir.
Okay, so let's first see resemblance with alkali metals. That means how it resembles with alkali metals. Resemblance with alkali metals. So how it resembles with the alkali metals? Number first is the electronic configuration. It has same electronic configuration as shown by the alkali metals. So let's see how. For example, if you just talk of hydrogen, hydrogen, it has only one electron in the valence shell, right?
Yes, sir.
Its electronic configuration is 1. Then if we just talk of lithium, its atomic number is 3, so its electronic configuration will be 2 comma 1, right?
Yes, sir.
If we just talk, if we just talk of sodium, it will be 2 comma 8 comma 1. So if you just see here that In all these elements, last they have only one electron in the last shell, right? So it is 2
Yes,
comma
sir.
8 comma 8 comma
The
1.
valence is 1.
Exactly. That's also their valency is 1. Their valence electron is also 1. So this is how it resembles. Otherwise, hydrogen is it is a gas. All other these are alkali metals, but still it resembles. That's why we are just placing it there in the group first, because its electronic configuration it is same with these alkali metals. Hydrogen has one valence electron. All other alkali metals they have also one valence electron. So this is the first resemblance, that how it resembles with the alkali metals, right?
Yes, sir.
Okay, let's see the next point, that how it resembles. Next is that alkali metals they form positive ion, and hydrogen also forms the positive ion, right?
Yes, sir.
That means we can say that electropositive nature. I hope you remember what do you mean by electropositive.
Yes,
Electropositive means
sir. They
tendency.
carry a positive charge when forming an ion.
Exactly, electropositive means tendency to lose electron. Electropositive character. Okay, I will write it here. For example, if you just talk of here the hydrogen can lose its electron and it can form the cation, that is H positive, right? And same property is shown by alkali metals. They can also easily lose electron and they form the cation, that is sodium. It loses one electron, it forms any positive cation. They easily form the cation. They have tendency to lose electron, and hydrogen has also tendency to lose electron. So now can you tell me what is this known as, this H positive it is known as? I have already told you what is this
Sir,
name.
it's called a pro cation.
Yeah, it is cation. Li positive is also cation, Na positive is also cation, but this H positive it has special name. What is that?
Uh,
What is now there left when it has lost electron? What is there? There is the proton, so that's why it is known as proton simply.
yes, sir. Oh, it's only a proton.
Exactly, it is now only a proton, so you have to remember that H positive it is known as proton. Got it?
Yes, sir.
So that means we have seen this hydrogen it resembles in this electropositive character also. That means hydrogen has tendency to form this cation by losing one electron, and all other alkali metals they have also the same tendency. They also lose one electron and they form the cation. And now if we just talk of another resemblance, that is the valency. So can you tell me, all these have same valency, isn't it?
Yes, sir.
Valency and oxidation state. If we just talk of either valency or the oxidation state, it will be same. So what is the valency shown by hydrogen? It is 1, and
1.
all other alkali metals they have also the valency 1, right?
Yes, sir.
Exactly. Now if you just talk of oxidation state, then what will be the oxidation state of alkali metals and hydrogen? It will
Sir,
be
1,
plus.
sir. Plus 1, plus 1.
Exactly. I have told you that whenever you will write valency, there is no need to write any sign. But whenever
Yes,
you
sir.
write the oxidation state, then you have to mention the sign, whether it is negative or whether it is positive. So
Yes,
that
sir.
means it is
But in school, ma'am told us to write the sign when they ask valency because she didn't teach us oxidation state.
okay. No problem.
Right?
You can write. You can. I told that in valency we don't write, but in case of oxidation
Yes, sir.
state, yeah, we have to write this.
I know.
Okay, so valency. So that means it resembles, hydrogen resembles with the alkali metals in having same valency, right?
Yes, sir.
Exactly. And now similarly, if we just talk of next resemblance, let me write it here, fourth one. So that is formation of salt. That is formation of salts. Can you tell me that alkali metals they form salts? Yes, they easily form,
Sir.
isn't it? For example, sodium. Sodium when it reacts with the
Sodium,
chlorine,
sodium
exactly, it
chloride,
forms exactly sodium chloride. It's a well-known
common
salt.
salt.
common salt, exactly, rock salt. And similarly, we are having potassium chloride, we are having lithium chloride. All these are salts, right?
Yes, sir.
But can you tell me hydrogen, does it also form the salt?
Yes, sir.
Answer is yes. Answer is yes. For example, sodium
Hydrogen
hydride.
chloride.
No, hydrogen chloride is not the salt. That is a covalent compound. That is actually acid. HCl is acid.
Yes, all right.
Hydrochloric. Yeah, it is actually there is covalent bond. It is a covalent compound. Salts have ionic bond there. So NaH is your salt. Similarly, potassium hydride is they are known as hydrides. The salts of hydrogen they are known as hydrides. Just we are having sodium. Okay, I will write it here. It is known as sodium hydride. Sodium hydride, and this will be known as calcium hydride. Right? Got
Yes,
it?
sir.
So you have to remember that just as alkali metals they form the salt, hydrogen also forms the salt. It can react with these alkali metals and it forms these are the salts, that is NaH, sodium hydride. So can you tell me what is actually this sodium hydride? It is just like this. That means it is Na positive and H negative.
H pos. Oh, yeah.
It is salt. Salt means it should have ion, that is
So
cation
it
and
gains
anion.
one electron in this case.
Exactly. In this case, it gains. So this is very important. Hydrogen has dual character. So that means it can lose its electron and it can form H positive, but it can also gain electron, and at that time it forms H negative. And what is the name for this H negative? It is known as
Electron.
no. It is known as
Then is it
hydride ion. It is known as hydride ion. So that is why we call them as sodium hydride, calcium hydride, potassium hydride. Got it now?
yes, sir.
That is why we are naming them as calcium hydride. Similarly, magnesium hydride. What will be the formula of magnesium hydride? It will be
Sir,
MgH2.
MgH2.
Exactly. So have you noted down this? Shall I move to the next?
Yeah. 1 second, sir. Yes, sir, done.
Yes, sir, done, sir.
Okay. So from these points, what we have got? We have got that it resembles. Okay, what point it was? I think fourth one, right? Let me write the fifth one. Fifth one is that hydrogen and alkali metals they act as a reducing agent. Do you know what is reducing agent?
Yes, sir.
That
An
means which
element which donates hydrogen in order to element.
you can also define like this, that reducing agent is that any substance, any element which helps in reduction, which helps in reduction, which helps in reduction. So tell me that when it will help in reduction, what it will itself undergo? That means it will itself undergo
Oxidation.
oxidation. Exactly. So itself undergoes oxidation. Itself undergoes oxidation. Remember this definition because it is used everywhere. So this is very
Yes,
important.
sir.
Reducing agent. A reducing agent is any substance, any element which helps in reduction. That means it will help us in reduction, in doing reduction of any other substance, but itself it will undergo oxidation. Got it? Now see, let's
Yes,
see
sir.
hydrogen. Now, can hydrogen act as a reducing agent? Easily, hydrogen acts as a
Yes,
reducing
sir.
agent. It can reduce any. For example, if I will just write here,
Sodium.
uh, this is my ethene organic compound, that is C2H2. It is known as ethene, right? There is carbon-carbon double
Yes,
bond.
sir.
When we just react it with hydrogen, it will just reduce this ethene to ethane. That means it will form CH3, single bond CH3. It is known as ethane. So what is this reaction? This reaction is a reduction reaction. So that means
Yes,
hydrogen here acts as a reducing agent, correct?
sir.
Okay. So alkali metals, they also act as reducing agent. alkali metals, they also act as reducing agent. For example, if we just talk of lithium, sodium, potassium, so they also act as reducing agents, because they can easily lose their electron. As I have told you that sodium, it can easily lose its electron, and what it forms, it forms any positive. So any such element which can lose its electron, so that means it has undergone actually oxidation. So when it itself undergoes oxidation, so that means it will act as a reducing agent. Got it?
Yes, sir.
If you can remember, I will write it here that if any element it loses electron, that means it has undergone oxidation. This is another definition of oxidation.
Yes,
So
sir.
okay, I will write it here. Oxidation means loss of electron and reduction means gain of electron. Oxidation means loss of electron and reduction means gain of electron. So can you tell me sodium, it has lost one electron. So what it has
So
undergone?
reduction.
No, it has undergone oxidation because it has lost one electron. Sodium
Oh,
has lost one electron, so it has undergone oxidation. So when it has undergone oxidation, therefore it will act as reducing agent. It is just opposite. If any element undergoes oxidation, so that means that will act as reducing agent. This is important. Have you noted down this?
yes, sir. One second.
Yeah, yeah, I am again saying that if any element loses electrons, so that means that has undergone oxidation. And if any element has undergone oxidation, so that means that will act as reducing agent. That will act as reducing agent.
Yes, sir. Done.
Okay, tell me here. I will just give you another example. That is example of reduction. Fluorine, it gains one electron, so it becomes F negative.
So
So
it's a
what
reduction reaction.
exactly? So this is a reduction reaction. So that means fluorine, it has undergone reduction. But can you tell me what this fluorine will act as?
It will act as the oxidation.
It will act as oxidizing agent,
Oxidation.
right?
Okay. Yes, sir.
Oxidizing agent. I will write it here, oxidizing agent. So one is your reducing agent, another is oxidizing agent. Got it?
Yes, sir.
So shall I move to the next page?
Yes, sir.
Yes, sir.
Okay. So from all these properties, what we got? We got that
Sir,
hydrogen
oxidation is loss of electrons, right?
oxidation is exactly loss of electron and reduction is gain of electron. I have written it here.
Yes, I just forgot.
Yeah, okay. Oxidation is loss of electron and reduction means gain of electron. If any substance, any element, it loses electron, so that means it has undergone oxidation. And if any element it gains electron or any substance gains electron, so that means that has undergone reduction. Correct?
Yes, sir.
Okay. So these were the various resemblances of hydrogen with alkali metals. Now let's see the resemblance with halogens. So that means this hydrogen it also resembles with the group 17 elements. So let me write it here, resemblance with group 17. So group 17, you already know they are known as halogens because they are salt forming, right?
Yes, sir.
And what are these? And these are just your fluorine, chlorine, bromine,
Bromine, iodine.
iodine, astatine, right? Okay. Now tell me here that how they actually resemble, how this hydrogen it resembles with these halogens. So number first is the electronic configuration. We have seen electronic configuration in also with the alkali metals, but also we will see it here. Let's see how. Hydrogen, if we just check it out, it has only one electron. Now if we just talk of fluorine, atomic number 9, so that's 2 comma 7. If we just talk of chlorine, atomic number 17, so that's also 2 comma 8 comma 7, right?
Yes,
So can
sir.
you tell how it resembles with these halogens? Where is the
So
resemblance?
the so the valency is one,
See,
They
actually here,
require one, sir. They require one electron to
exactly,
like
exactly.
complete their octet
Complete,
or duplet.
complete, complete their noble gas electronic configuration. For example, if I will just give one electron to this hydrogen, so that means it will become what? It will become your noble gas, that is helium, having two electron, right? Similarly, if we give one electron to this fluorine, it was 7, so it will now become 8. It will complete its octet, so it will become noble gas neon. That's atomic number 10. Similarly, if I will just give one electron to this chlorine, it will complete its octet, and therefore it will become the noble gas, that's your argon, atomic number 18. Got it? So that means all these halogens, they just require one more electron in order to complete their octet, and in
Or
order to
duplet.
actually, in order to actually become, in order to have the nearest noble gas electronic configuration.
Conflict.
Similarly, hydrogen, it also requires one more electron in order to complete its duplet. That means in order to become the nearest noble gas. So that means we can say that hydrogen, it has some similar type of electronic configuration as that of halogens. So have you got it?
Yes, sir. I'll just drink water.
Yes. Okay. So next is resemblance with the halogens. That is actually the electronegative character. Electronegative. Can you hear me?
Yes, sir. Hello.
Yes, sir.
Yeah. Okay. So now see here that these halogens, what are they? They are all electronegative. That means they have tendency to gain one electron, right?
Yes, sir.
Hydrogen has also the same tendency. That means hydrogen can also gain one electron and it will also form the anion. So that means hydrogen is also electronegative, right?
Yes, sir.
And I have already told you that this H negative, it is known as hydride ion, correct?
Yes, sir.
Exactly. So that means uh, this hydrogen, it resembles with these halogens, that is group 17 elements, in electronic configuration, in electronegative character. Similarly, the oxidation state, what you also call the valency and oxidation state. So in these halogens, can you tell me what is the oxidation state of these halogens?
-1.
Exactly, it is -1. Hydrogen also has -1. For example, if I just, as I have told you, the salts, that is NaH,
It's plus or
LiH,
-1.
exactly, calcium hydride. So in all these, you will find that hydrogen has -1. Sodium has +1 and hydrogen -1. Similarly, lithium +1, hydrogen will be -1. Here it will also be -1. Okay, but calcium will be here +2. Okay, so that means it resembles with these halogens, group 17, also in the oxidation state. And not
Yes, sir.
only that, it is also diatomic, that's atomicity. Hydrogen is diatomic and halogens, they are also diatomic, right?
Yes, sir.
So I can write that they have same atomicity. For example, if I just talk of hydrogen, it exists as H2. If I just talk of fluorine, that also exists as F2. Chlorine also exists as Cl2. Bromine exists as Br2, right?
Yes, sir.
So iodine as I2. So all these halogens, they are diatomic, they have atomicity 2, and hydrogen has also atomicity 2. Shall I move
Yes,
to the
sir.
next sheet?
1 second, sir. Uh, yes, sir. Yes, sir.
Okay. So now let's see the next one. Next resemblance is that is the non-metallic nature. Non-metallic nature. What is hydrogen? Hydrogen, is it a metal or non-metal?
It's a non-metal that shows positive valency.
Exactly, it is a non-metal. So when hydrogen it is a non-metal, tell me what are these halogens?
They're also non-metals.
Exactly, halogens are generally represented by this X. So they are also your non-metals. So you had to remember that hydrogen it resembles with these halogens in this non-metallic character. That means all these are non-metals. And not only that, it if we just talk of the compounds of hydrogen, compounds of hydrogen and halogen both are covalent. I'll write it here that compounds of hydrogen and halogen are covalent except group hydrides, which I have already written down. For example, if I just talk of hydrochloric acid, if I just talk of H2 molecule, if I just talk of hydrobromic acid,
F
I, yeah, all these are
F2.
covalent compounds. Yeah, exactly. H2O water, it is a covalent compound. Similarly, halogens also form covalent. For example, F2, for example, ICl, for example, BRF3. All these are covalent molecules. So that means hydrogen, it not only resembles with the alkali metals, it also resembles with the halogens, that is group 17 elements. So that means you could also place this hydrogen there with the group 17 elements. So that is why it shows anomalous behavior. That means its properties they resemble with the alkali metals and it also resembles with the halogens, that is group 17. Correct?
Yes, sir.
Okay, then let's see now the differences. That is how it differs, right? So first let's see the differences from alkali metals. Differences from alkali metals. Differences from alkali metals. So what do you think where this hydrogen, where does it differ from the alkali metals? Number first is the non-metallic character, as I already told, right?
Yes, sir. And the compound are not covalent.
Exactly. So non-metallic character, that means hydrogen is what? It is a non-metal. But if we just talk of alkali metals, what are they?
They're they're they form
They are
a
all
ionic bond or a,
metals.
yes,
When
sir,
I just
metallic
talk,
bond.
yeah, exactly. They form the metallic bond because they are metals, they are alkali metals, they are soft alkali metals.
Yes, sir.
So that is why it means that hydrogen it doesn't resemble with the alkali metals because alkali metals are all metals, soft metals. But this hydrogen it is a non-metal. It exists in the gaseous state. So that
Yes,
means
sir.
number second, if I just talk of its difference, that will be the atomicity. How hydrogen exists? Hydrogen exists as
H2.
H2. But what are other alkali metals? Alkali metals are monoatomic, right?
Yes, sir. LiNa.
So it is H2 is diatomic, and you will write that alkali metals, they are monoatomic. That means whenever you write them, how you write? You just write lithium as Li. You don't write it as Li2, right? Similarly, sodium as Na, potassium as K. You don't write, you never write K2, Na2, Li2. So this is another difference, right?
Yes, sir.
Okay, what is the next difference? That is the nature of compounds, right?
Yes, sir.
Hydrogen forms covalent compounds, but these alkali metals they form always the ionic compounds. Hydrogen can form covalent compound, but these alkali metals they just form the ionic compounds. Got it?
Yes, sir.
So just note down this.
Done, sir. Done, sir.
Sankar has complete.
Yes, sir.
Okay. So this is the difference from alkali metals, right? Now let's
Yes,
see
sir.
the
Sir,
difference
only
from
three,
halogens.
sir.
Yeah, you have to yet remember in this class only three. Another is
Yes.
that is the ionization energy, but you don't have studied what is ionization energy. Have you studied?
No, sir.
Okay, that means you have not studied that. Then let's see the difference from halogens. Differences from halogens.
They're not reducing agents.
Exactly, hydrogen acts as a reducing agent, but these halogens they don't act as reducing agents. They act as oxidizing agents, right?
Yes, sir.
Okay, you will write that hydrogen it acts as a reducing agent, but these halogens they act as oxidizing agents. Correct?
Yes, sir.
Yeah. Now, if we just talk of hydride tendency to form hydrides, hydrogen has less tendency to form hydride as compared to halogens. I will write it here that hydrogen has less tendency to form hydrides. While if we just talk of halogens they can easily form the hydrides, right? See, actually, hydrogen, I have written here that
How can
hydrogen has,
hydrogen form hydrate, sir?
yes, for example, what is
Like
this?
H2?
NaH? No,
Okay,
NaH
sir. Oh,
element.
I thought
What
like
is this?
hydrogen itself will like form HH.
Yeah,
Now means sir. Like,
it is just like this. It is sodium hydride, lithium hydride, potassium hydride. These are the hydrides, right?
yes, sir.
Okay. So if we just talk of halogens, that means here what actually how hydrogen exists. It exists as H negative. H negative, that means how it has become, how it is formed. That means hydrogen gains one electron, then it will become, right?
Sir.
So that means hydrogen has little tendency, it has less tendency to accept electron because most of the time this hydrogen it loses one electron, but to gain electron it has less tendency. Got it?
Yes, sir. So what
Yeah.
about halogens?
Halogens can easily gain electron. For example, if we just talk of fluorine, it can easily gain electron to form F negative because they are highly electronegative. Hydrogen is not that much electronegative. Fluorine it is highly electronegative. It is having highest electronegativity in the whole periodic table.
Oh, okay, sir.
Highest electronegativity. So note down this because it is sometimes asked that in the periodic table which is highly electronegative, it is fluorine. It is the fluorine. Fluorine has highest electronegativity. So that is why you have to remember that hydrogen it has less tendency to accept the electron, but halogens they have very good tendency. They can easily accept the electron. Correct?
Yes, sir.
Exactly. Now, if we just talk of oxides, hydrogen, what type of oxide is formed by hydrogen? Hydrogen forms
Hydroxide
which oxide? That is water, right?
and hydroxide, sir.
Hydroxide is just like this. For example, if we just talk of lithium hydroxide, that is LiOH. Sodium hydroxide,
Okay, sir.
that's NaOH. Yeah, these are the hydroxides. These are actually the bases. That's why they are known as alkali metals, because these are water soluble bases. I'm just talking of oxide. I told that this water it forms this hydrogen, it forms the oxide, that's water, so it is the oxide of hydrogen. What is this H2O? Is it acidic oxide, neutral, or basic? It is
Sir?
neutral. Water is neutral oxide, right?
Yes, sir. It's not acidic.
Exactly. Now if you just talk of oxide of halogens, for example, if it is Cl2O7, it is the oxide of chlorine, right?
Yes,
What is
sir.
this? What is this? Is it acidic, basic, or neutral?
Sir, it's not acidic, sir.
It is acidic oxide.
Oh,
It is acidic oxide. So that means hydrogen differs. Hydrogen forms normal oxide with oxygen, but these halogens they form acidic oxide. Got it?
yes, sir.
Yeah, this is very important. For example, if you, it is not only chlorine, if you just talk of oxygen, iodine, I2O5, this oxide is also acidic. So that means halogens they form acidic oxides, but this hydrogen, that is water, it is a neutral oxide. Correct?
Yes, sir.
Okay. Shall I move to the next page?
Yes, sir.
Yes, sir.
Okay. Now see the next one difference. Next difference is that uh, hydrogen do not have any lone pair electron, right?
Yes, sir. It's always complete.
Exactly. Has not any unshared electron pair. It has not any unshared electron pair. What you also call it as lone pair, right?
Yes, sir.
Okay, I will just give the example. For example, if you just talk of H2 molecule, hydrogen, it was only having one electron. Another hydrogen atom came and it also gave one electron. So there is mutual sharing. So both have completed their duplet, right?
Yes, sir.
Now tell me, is there any lone pair on the hydrogen?
No, sir.
No. But if you just talk of halogens, let me talk of
Like,
fluorine or chlorine. Fluorine has how many valence electrons? Seven, right?
yes, sir.
So among these seven, it has just shared only one electron. So that means it has three lone pairs, right? Three lone pair here. And
Yes.
another fluorine, it will also have the same. It will also have the three lone pair
Sir, why
electrons here.
can't it form a triple bond and have two lone pairs?
What is the valency of halogens?
One, sir.
Yeah, one means they will form only one bond. How can they form triple bond? For example, if it is nitrogen, what is the valency of nitrogen?
Three.
Exactly, it is three. So that is why it forms the triple bond. If we just talk of nitrogen, it forms the triple bond.
Okay, sir.
Yeah, this can form, but chlorine doesn't form the triple bond because that's its valency is not three there, and chlorine is having very bigger size and it is less electronegative, so that's why it will not form the triple bond. Actually, in this triple bond, there is pi bond. There is one sigma bond. There are two types of bonds. One is known as sigma bond. Another is known as pi bond. There is one sigma and two pi bonds here in this N2 molecule.
Okay,
Pi
sir.
bond is yeah, pi bond is actually formed only by those elements which are having very small size. Okay, I will write it here. This is the extra information you can remember, that pi bond is formed by only those elements which have very small size, and high electronegativity.
Yes,
Got
sir.
it? Yeah.
Yes, sir.
So chlorine, it is having bigger size and it is not very much electronegative. So that's why it will not form pi bond.
Yes, sir.
Okay. So what we got? We got that hydrogen, it resembles with the alkali metals, correct?
Yes, sir.
And not only that, it also resembles with the halogens, correct?
Yes, sir.
And then what we got, it also differs from the alkali metals and it also differs from the
The
halogens.
halogens.
That is why we say that this hydrogen, it has anomalous behavior. So that's why hydrogen shows anomalous behavior. Anomalous means it is not
Like a
neither
confused.
exactly confused. It doesn't has any proper position in the periodic table, because if we say that if it resembles with the alkali metals, so it should be placed in the group first, but it also differs from the alkali metals. So then if we say that it resembles with the halogens, so it should be placed there, but it also differs from the halogens. So there isn't any proper position in the periodic table. So you will write that no proper position in periodic table. Got it?
Yes, sir.
So that is why sometimes it is known as this hydrogen is known as a Ruggie element. I will write it here. Hydrogen is known as ROGUE, a Ruggie element. Ruggie, it means that it shows anomalous behavior. Got it?
Yes, sir.
So this was the position of hydrogen in the periodic table, and its introduction, that why it is known as hydrogen. And can you tell me where it occurs? Hydrogen, it occurs in the Earth's crust as well as in the atmosphere, air, right?
Yes, sir. Like in it's a part of air.
Exactly, in some
So
part of air.
how does it occur in lands, Earth, sir?
Yeah, in the form of salt, just as I have told that hydrogen can also form the salt like sodium hydride.
Oh, okay. Like
Not only that, you just see water. What is water?
H2O.
Exactly, it has also hydrogen in this. So that means this water is also in the Earth's crust. So hydrogen occurs in the Earth's crust in the combined state. Combined means with other elements, right?
Yes, sir.
Exactly. And it also occurs in the gaseous state in the air or atmosphere. So with this, we completed its position. Then in the next class, we will discuss the various other properties, the reactions, the preparation of this hydrogen. So is there any doubt, any question in today's lecture?
No, sir.
No, sir. Clear.
Okay, then have a nice day ahead.
Sir,
Thank you.
and it is not doubt, but I sneezed 53 times this class.
Oh my God. So just take care of your health.
I,
Get well soon.
I don't know, sir. Like everyone in our school is getting flu for some reason.
Yeah, even I got cold yesterday. I was absent today.
Actually, see, one is the temperature is very high, and maybe there is some flu infection. So you have to take the measures, right? Prevention
Yes,
measures.
sir.
Exactly. And just take the medicine, and you will get well soon.
Yes, sir.
Yes,
Okay.
sir.
Have a nice day
Hey,
ahead.
Conwell, today I told a
Thank you,
speech in the
sir.
assembly day,
Most welcome.
What speech?
like about the Chandrayaan 3 for 5 minutes.
Nice. Okay, so thank you, sir. Bye.
Okay, sir. Thank you, sir. Bye, sir.
Bye.